What an honor to have an astrophysicist with us tonight. I'll let you introduce yourself and your project.
Well, thank you. My name is Edwin Hubble. I was born on November 20th, 1889 in Marshfield, Missouri, and then I spent most of my childhood in Wheaton, Illinois. After receiving degrees in mathematics and astronomy from the University of Chicago, I dedicated my research to exploring our galaxy and its neighbors. Originally, the scientific community was trying to determine whether the Milky Way was the one and only galaxy, and I was a part of that by determining that the Andromeda Nebula was not a star cluster but its own galaxy. We found many, many galaxies, and I studied 46 of them for my work. Once we found all these other galaxies, I started working to see, how they were interacting with our own.
So, what exactly were you aiming for?
Again, originally we were just looking, and then came Andromeda and more galaxies. Once we, being the scientific community, determined that the Milky Way was not the only galaxy, I wanted to know how they worked with our galaxy. I wanted to figure out how far apart they were, how fast they were moving, and I was able to use the light spectra to do this. I looked at the redshift of a galaxy's spectrum. The redshift was larger for galaxies that were faint or far away, meaning that they were moving away from Earth pretty quickly. During this research, I determined that the universe was expanding and introduced the first ideas of the Big Bang Theory, being that everything came from one central point and then started moving away at a uniform rate.
Obviously, your project was located in space, but where did you center your work?
During the 1920s and 30s, while I worked at the Mount Wilson Observatory, it was home to not only me, but also the then largest telescope in the world, the Hooker telescope. This telescope was critical to my research, and it was the one that I trained on Andromeda Nebula. It was located in Los Angeles, California.
What else was going on in the world during your research?
The Roaring Twenties are pretty well known, especially in the US, but most notably outside of the physics world. Women were given the right to vote, which extended women's rights, and another major buzz was the birth of mass media. In addition to that, the jet engine was invented and the electron microscope, but that was for something just a little bit smaller than a galaxy, which is what I worked with.
Did you have anyone in particular that you worked with?
My colleague from Mount Wilson was Milton Humison. He worked with me on my project, and what a man Milton was. He began as a mule driver during construction of the observatory and then became a janitor, after that a night assistant. Finally, he was an astronomer. He and I estimated the universe to be expanding at about a rate of 500 kilometers per second per megaparsec. I also did some research with the mathematical physicist and chemist Richard C. Tolman, but the data we collected was a little bit more uncertain and less notable. He was a great friend of mine, a great aide, and an excellent scientist.
What was your role in the project?
Well, I headed up my own research. I worked in conjunction with others in the scientific community to prove that the universe was and is expanding. Many had also thought of expansion as a possibility and posed theories using Einstein's general relativity to support their ideas. But my data was released in 1929, and it was the first of its kind. I studied 46 different galaxies to conclude that the universe was expanding uniformly, and it was a major contribution to the scientific community, being the first set of hard data.
What impact did your project have on the physics community?
First was discovering that Andromeda Nebula was a galaxy, which opened hundreds of doors to the physics community. My research most notably produced Hubble's law and the Hubble constant. Hubble's law says that the dominant motion of the universe is a smooth outward expansion. From Hubble's law came Hubble's constant, and the expansion factor, which I estimated to be again 500 kilometers per second per megaparsec, but it's changed just a little bit and now bears my name. My data was critical to proving that the universe was indeed expanding, and it gave the physics community a foundation to work off of when looking outside of our galaxy.
How does it feel to know you have left a legacy such that your processes and your telescope are still used today, decades later?
Many people expected me to have a legacy as a boxer. Growing up in my hometown, that was my gift. And many people thought that was how I was going to leave my mark. To me, though, hearing people say that I revolutionized our understanding of the universe is so much more significant. I now have a law, a constant, and a telescope that bear my name. They're the tools for the future, and people thought my work was important enough to move forward and add to it. My work has outlived me, and that's a comforting thought that I worked so hard to research space, and someone else has brought it forward, and it's still used today. I don't know if you guys know, but I was up for the Nobel Prize, if only there was a category for astronomy. But that isn't it. I'm unconcerned with names and prizes. I have expanded the knowledge of not only the scientific community, but the people around the world. That's what our minds do. They expand, just like the universe does. And to know that I was such a notable part of that is incredible.
Thank you so much for talking with us tonight.
Thank you guys so much for having me.